So, any volunteers for Jabber or anybody on the Jabber? Okay, so plan to start. So this is Lwig working group. Make sure you're in the right room. So because it's Friday, so I want to keep it to time. Okay, while people is waiting, and our responsible AD is still probably on the way. So unfortunately, my co-chair Robert could not make to Berlin this time. So, this is not well. You probably have read this hundreds of times. And any volunteers to take minutes? Okay. Any volunteers to see if there's any people on the Jabber? Matthias. Matthias, could you help with the Jabber? Are you on it? Or anybody on the Jabber? Oh yeah, sure. Thank you. Okay, thank you. What's your name, by the way? Okay. Great. I actually have a volunteer for the minutes taker who is on the way, but I think for the general part it's okay for his absence. Okay, Terry. Yeah, we hand out the blue sheet. It's on the way. Please sign it. Okay, our responsible AD is coming. Great. So this is status of the working group document we have right now on the desk. So recently we published the IKV2 minimum implementation guidance, which is RFC 7815. And also we have the Lwig COAP over scenario document, which is in the RFC queue. And we have another document related to COAP implementation, which has been discussed many times over the years, but now the status has been expired. I talked with Matthias yesterday, and he said he has some plan about some update of this document recently. And we have another document about energy efficient implementation guidance, which has gone through the working group last call, but there was a silence during the last call. So I cannot say that there's any consensus about this document right now. So we are still waiting for more views, and probably we can kick off the other working group last call for this document if we really need it, and we can have the sufficient view of this document during the process. And we have another good document about the TLS implementation, and which has been expiled, waiting for the authors to, if they have interest or they still think this is useful, to continue. So that's pretty much on my side. And so we have 4 talks today listed here and also in the agenda. So because it's Friday, I really hope every presenters to be on time precisely, because otherwise people will blame me. So yeah, let's hand over to the first presentation, Carlos.
Okay, hello, my name is Carlos Gomez, and I'm going to present this initial version of the draft entitled TCP over constrained node networks. I'm from UPC&I to CART, and my co-author is John Cookroft from the University of Cambridge. So first of all, let's take a look at the motivation for this draft. At this moment, we have a situation where several application layer protocols are being used for the Internet of Things. For instance, we have the CoAP, the Constrained Application Protocol, was originally designed over UDP. However, there is currently a CoAP over TCP specification being developed. And actually the main reason for this CoAP over TCP draft is the need to overcome middle box problems. Then, on the other hand, we have HTTP 2 and even HTTP 1.1, which are also being used or considered for the IoT. And other application layer protocols such as MQTT are also in fact deployed in the IoT. And all of these are using TCP as the transport layer protocol. So TCP is being or will be used in many IoT scenarios. However, it has not received much attention yet, and in fact, it has been sometimes actually very criticized. So the main goal of this document is to offer simple measures to allow for lightweight TCP implementation and suitable operation for constrained node networks. Well, this work actually is related with more than one working group. For instance, this is related with CORE, which is the working group which specifies CoAP and its related framework. Also TCPM, which defines the TCP maintenance and minor extensions. And also this working group, which has been actually suggested as the home for this draft. I understand that at some point we'll have some discussion or confirmation about this. So on the actual content of the draft, first of all, we should take into account which are the typical characteristics of constrained node networks, which is something that is well known in this working group. And actually it's defined in RFC 7228. So constrained nodes are devices which typically exhibit significant limitations on processing and memory, which limits the complexity and the implementation footprint of the protocols being used. Then there may be also significant limitations on energy resources, which means that the messages involved in communication and the size of those messages should be reduced as much as possible. Then these devices typically use lossy links, which means links with high bit error rate. That's mostly because typically wireless technologies are used, but also sometimes there are other wired technologies quite common in some IoT scenarios, which however are also harsh and offer some high bit error rate, such as power line communications. With regard to the network topology, in some scenarios we may have star networks, so that this ends up with being a single hop communication scenario between a constrained device and the router, for instance. And in some other cases, there's a mesh or multi-hop deployment. So let's take a look at the several recommendations about how to use TCP in these environments as per the current version of the draft. So about the maximum segment size, we have that IPv6 requires support for 1280 byte packets. However, many of the link layers which are used typically in constrained node networks offer very reduced link layer payloads, such as tens or few hundred bytes. So this means that in these cases, an adaptation layer such as 6LoWPAN or 6Low is used. However, this ensures that packets of a size of 280 bytes can be actually transmitted or received through these links. However, it is not so clear that support for packets of a greater size than this is still allowed, is still enabled. So the idea is that in order to avoid IP layer fragmentation, this document indicates that the maximum segment size cannot be greater than 1220 bytes, and in any case it shouldn't lead to an IPv6 datagram size exceeding 1280 bytes for this kind of links. Then about the window size, at this moment the draft states that a stop and wait operation has to be used. This is because quite often there have been comments, for instance, I remember in the core working group, that for the end-to-end reliability mechanism for co-op, we shouldn't reproduce, let's say, the complexity of TCP. However, the result has been a stop and wait operation by default in co-op. So this seems to be accepted by the community which is dealing with this protocol and the related environments. So the idea was to say, well, possibly the same can be achieved with TCP. So based on the feedback that we've received so far, it seems like, okay, maybe it's better to maybe recommend or explain which are the benefits of stop and wait, but maybe not forbid other options. So then another matter is how we can enable the stop and wait operation if we really want to use it. Another section focuses on the RTO algorithm. So in this case, what is currently in the draft is that we actually recommend the use of the same algorithm that is being proposed as some advanced mechanism for co-op. Actually, that's because we have experimentally evaluated which is the performance of this new algorithm, which is called COCO. And we have compared it with other algorithms, such as the one in RFC 6298 and many others. And we believe that it performs very well in these kind of environments. So this is why we are actually recommending its use. Some of the features of this mechanism include, well, in addition that this is based actually on RFC 6298, it also includes using weak RTTs, a variable backup factor, an aging mechanism, and dithering. So this has shown to lead to good performance in terms of PDR, settling time after a burst of messages, and fairness. Another aspect is about the lifetime of a TCP connection. So in the draft, we currently state that the TCP connection should be kept open as long as possible. Well, actually, there's some indication in quantified terms, which is that if data is going to be sent in the next 2 hours, then the connection should be kept open. The idea is to minimize the overhead of establishing new connections. Then, on the other hand, we have that keep alive messages may be used, may be supported by a server, and in the scope of constrained scenarios, this may be useful to clean inactive state for inactive connections state for devices which have memory limitations. However, the keep alive timer cannot be set to a value lower than 2 hours. So this actually has some issues, such as it doesn't guarantee avoiding middle box problems, because sometimes the bindings and the state kept at the middle boxes is released earlier than 2 hours. So the alternatives might be okay. Maybe we have to anyway establish TCP connections frequently, or maybe application layer heartbeat messages can be used. Also, based on the feedback that we have received, something we should take into consideration is TCP fast open. This would have the benefit of embedding data already in the SYN packets when a new connection is established. However, we have to make some detailed analysis here, because TCP fast open involves negotiating a cookie, which has to be updated relatively frequently. And then also the cookie has to be included in the SYN packet, which also increases message size. So we really need some detailed analysis here. Okay, then there is the mechanism of explicit congestion notification, which we understand that may be used in constrained node networks. At this moment, the draft was only allowing stop and wait operation. However, as I mentioned before, probably in the next version, this constraint will be released or relaxed. The idea is ECN can be useful to trigger congestion control mechanisms earlier than maybe after the expiration of the RTO, or earlier than waiting until the reception of 3 duplicate acknowledgements. And even in the case of having a single segment window, it's still useful to trigger congestion control measures. Then a consequence of the original stop and wait approach that was enforced, or is currently still enforced by the draft, the idea is that then there are several options which would not be used or wouldn't make any effect, such as window scale, TCP timestamps, selective acknowledgements. However, we have that for the next revision of the draft, based on the feedback we have received, probably since options 0, 1, and 2 have to anyway be parsed, then we may phrase in a different way the approach in this regard, saying that we may ignore, or an implementation may ignore options that are not really wanted. And if anyway stop and wait is not going to be the only option, then maybe some of these options might be relevant, such as, for instance, selective acknowledgements. Finally, with regard to explicit loss notifications, this is something which could be useful to distinguish whether a loss is due to congestion in the network or whether it is due to corruption. This will be useful here because we are dealing with lossy links in constrained node networks. However, this remains mostly as experimental work. It hasn't actually been widely deployed and hasn't been really standardized by the IETF. So there are several further items we should take into consideration for future revisions of the draft. One thing is to clarify the scenarios we are considering. For instance, a major scenario coming actually from one of the main motivation items for the draft is to explain that we have sometimes a constrained device which may want to communicate with some unconstrained device on the internet. So we need to detail which are the implications of this scenario. Then something which has been suggested is to consider delayed acknowledgements, which is the role of this mechanism in this kind of scenarios. We need to analyze whether we can benefit from this mechanism and in which way. And I think that, especially in the context of the Lwig working group, this document, we understand that it should collect experience from implementation and deployment of TCP in constrained node networks. It would be great to know if people have had experience, if something has gone wrong, what has happened, so what is working well, what is not, and it would be great to be able to collect this kind of valuable information in this document. And also, there is this overall comment about the approach of the document, by which probably we should be more flexible, and even possibly removing maybe part or maybe even all of the RFC 2119 language. So also we'd like to thank a lot everyone for the great feedback we have received from people in this working group, also in the core working group, and also in TCPN. So thanks a lot, everyone.
Yes, thank you, Carsten.
Carsten Bormann. First of all, I think it's really a good thing to have a document like this. So I think that it's good that this work has been started. I think the document could be a little bit more explicit with respect to the situation that we often have a very asymmetric situation here. I mean, it's not the links that are asymmetric, it's that the implementations at the two ends are asymmetric. So one question, for instance, that comes up is there anything that a less constrained implementation can do to help the constrained implementation? Other example, on the MSS side, the constraint side may know more about its fragmentation properties and may, for instance, set the MSS to 250, and would be interesting to see what happens in particular in IPv6. One detail maybe at the start of your slides, we often forget that there is another IoT protocol that is being used on TCP, which is XMPP.
Yeah.
So we shouldn't be forgetting that. Yeah, I think that's all that came to mind.
Okay,
Thanks.
so I would like to cut the line. So, and also make your comments short. Thank you.
Okay. Oliver Harm, INRIA. Yeah, I agree with Carsten. I think it's very interesting and required work. And I was wondering, like a couple of years ago, there was a draft about TCP header compression. I think it was in the 6LoWPAN group. And I was wondering if you have considered, or if you looked at this old draft, or if you have considered some other mechanism for header compression.
Well, it is that if the TCP header compression document was, let's say, in progress or alive, probably this document would report that. I don't know if the approach should be different. I know that, yeah, there's this draft relatively, yeah, which has been inactive for a while. And I know that there are people who are interested in maybe reviving this kind of work. So then I don't know which should be exactly the relationship between this document and that document. But yeah, I agree that having TCP header compression would be absolutely beneficial.
Okay. And just one small comment. I don't know if you're aware, but there is ongoing work on a TCP implementation in Riot. So actually the main author of this implementation is in the room. So maybe that could be interesting for you to play with.
Yeah, that would be great. And if you have any kind of feedback, or we may just discuss this kind of stuff, it will be helpful. Thanks.
Okay, thanks.
Carrie Lynn, I think this is great work too. I had a comment and a question. First, my understanding of RFC 2460, and this remains in the BIS version, is that nodes, this is not something we've talked about a lot, but it says that nodes have to be able to assemble an MTU at 1500 octets after fragmentation. So I just wanted to point out that there may be some constrained implementations that actually support an MTU of that size. So please don't limit yourself to 1280. You know, keep that 1500 number in mind. My question was going to be about running code. I just heard the gentleman from Riot speak. I would mention that there's already TCP implementation in Contiki. I don't know if it could be lightened up, using this, using your techniques, but it'd be really interesting to take a look at that.
Yeah, thanks.
Hi, my name is Michael Schorf. I'm speaking here as chair of TCPM. But in general, I think this is an interesting document. Probably this is the right working group to document how to implement TCP in a lightweight way, and I see value in doing that. I don't see any value in changing the TCP spec in this working group here. You're invited if you see a need to change anything with beyond what the TCP specifications allow, then I think this has to be homed in TCPM. We are open to such work, but I think you should stay within the limits of the TCP specification, which gives you a lot of opportunities, but you should please stay within the limits. And if you change the protocol, please come to TCPM.
Yes, absolutely. So I can't agree with more.
Okay, Suresh Krishnan, 80 hat, so I'm skipping the mic cutting. So, like specifically like slide 12, like doesn't belong here. So there's something you need to do. And as logistics, right, stuff in slide 12. But for example, right, like, so it doesn't belong here, so it needs to go. But as logistics point, so if the working group decides to adopt this document, we're going to get a shepherd from like transport somewhere. So Media here, promised to get us a shepherd from transport to get this through. So it gets the kind of review. And one more thing that would be nice to do is like do frequent sync ups with TCPM. So probably like every other meeting cycle or something, like go back to TCPM, show what the state's in, if there's anything open, just keep the stuff synced so we don't get a late surprise in the IESG at the end. Thanks.
The nice card. No, wait, the nice
Hi,
card.
Carlos.
Thank you. Yeah, we can discuss on the mailing list. Yeah. Next one, Mohit.
Thanks, Ann. So I have a lot of slides. I'll try to go through them quickly. This was our draft documenting our experiences with public key cryptography on small devices. So by small devices, I mean really small devices, devices that have 8-bit microprocessor and 3 to 5 kilobytes of RAM. We basically wanted to see three things. First, what kind of libraries are available for me as a developer? So what kind of crypto libraries I can use? Second thing that we wanted to see was how hard was it to actually use this library. So was it a day of work, or it required more hacking? And the third thing was what kind of performance we can get with these libraries that already exist. So for all my measurements, I use this Arduino Mega board, which has a 8-bit microprocessor. So the first thing that we did was use RSA, and no surprises there. For a reasonable key length, the performance was pretty undesirable, and it was very slow. So if you look at key size of 2048 bits, which is what you would assume, or probably even bigger, the execution time for modular exponentiation and signing with the private key was actually pretty slow. So then we looked at libraries that support elliptic curve digital signature algorithm. Bear with me for a couple of slides, and I'll explain why we were focusing on ECDSA and not some of the other algorithms. We found 4 libraries that support ECDSA for small devices. So Relic, Micronacle, Vicelib, and TinyECC. There's also Matrix SSL and Polar SSL, but they are more focused for 32-bit devices, and we wanted to run our code on 8-bit devices. So we didn't get any numbers from those libraries. This is a graph to give you an overview of some of the numbers that we measured. I don't know if all of you can read back there, but the important takeaway is that in less than 3 kilobytes of RAM, you can actually do signing operation in less than a second. And for one of the cores, which is Circle, you could actually do ECDSA signing in less than 300 milliseconds. So it was actually 261 milliseconds. Uh, the library had actually implemented some mathematical optimizations directly in assembly. So this goes to show that if you are really persistent enough, you can get the numbers really down. Some of the cores that were there on the previous slide are probably not recommended anymore. So something like P256 or Crypto Forum is now specifying the Edwards curve 25519. Something like that would be probably more sensible to use on the small devices. We found some numbers for the same Arduino Mega board. For signing, it was 1.4 seconds. And for verification, it was 2 seconds, which may not be ideal in all scenarios, but bear in mind this was on an 8-bit processor. So we had the discussion in the ACE working group about the lighting use case, and it might make sense to just use a 32-bit processor because it's cheaper to actually get them. And in the lighting use case, you don't actually have the problem of energy harvesting or low power supply. You have all the power you need. So now I come to the slide why we wanted to measure ECDSA in particular. And basically we wanted to see if we can develop a full-fledged application where a sensor device is not a co-op server, but a co-op client. And basically it sends signed updates to a proxy, and this proxy would then serve data on behalf of the sensor. So the proxy registers the resource to the resource directory, and the client, any client that is interested in the data does a lookup on well-known core, gets the location of the proxy, and then gets the signed updates from the proxy. So basically you do end-to-end data authentication from the sensor to the client, even though there is an intermediary in between. And we had the same discussion yesterday in core. This kind of object security is kind of very helpful when you have intermediaries in between. So we implemented the co-op client and all the crypto stuff. We did JSON web signatures. We represented the keys as JSON web keys. We implemented the proxy and the resource directory on a x86 machine. And I'll just show the important numbers. It's like it was possible to do all of this, including, the network layer, UDP, everything in less than 5,000 bytes of RAM. So this goes to show that if you really put some effort into it, you can get the numbers actually quite minimal implementation. So what we learned from this is, of course, our platform was unnecessarily restrictive. So normally you would choose something like a 32-bit ARM processor or something more powerful. But our point was that if you can do on such a small device, of course, you can do it on 16-bit and 32-bit processors faster. And as is now well known, it actually costs you more to turn on the radio and send and receive messages than it costs you to do the crypto. So it would make sense to choose the right platform that can do the crypto that is needed. Yeah, there's no good reason to choose platforms that don't provide sufficient computing. So this was the implementation part. So what we implemented, the whole application, the client, and everything. And then we have the guidance part, or so to say, we discuss some of the trade-offs. And in the draft, we currently have discussion about symmetric key versus asymmetric key. And of course, a lot of people have this belief that symmetric key crypto doesn't scale, which is somehow a misconception because cellular network authentication, which is one of the largest deployed cryptographic security deployments, actually does use symmetric keys. However, we don't believe that scale should be the important deciding factor. It's actually what you want to do in your application. So if it might make sense to do this asymmetric crypto operations at the beginning to do the key exchange, then derive a symmetric key and use that. However, if there are proxies and intermediaries or the connection is very short-lived, so think of if you're using a phone to open a door lock, you might actually want to use something like data object security. So we have some discussion on trade-offs of doing security at the different layers. Of course, linked layer is good and useful, but it can be problematic because it only protects the first hop, and many of them use group keys. So if the key gets compromised, you can have all sorts of problems. Then we have IPsec and PANA at the network layer, and our favorite TLS and DTLS at the transport layer. And they work fine as long as you don't have middle boxes in between. But if you do have middle boxes in between, something like the application that we did where you sign and send objects to a proxy in between, and that ensures end-to-end data authentication, might be actually useful. And of course, if you do this unidirectional communication where the sensor only wakes up once in a while and sends signed updates, you need to ensure that there is freshness. So you need some way of protecting replay attacks. And we have some guidelines on how you can do that. So of course, there is sequence numbers and timestamps. And if you have too short sequence numbers, they can wrap around. If you have too long sequence numbers, your packet size grows, and how you can get around that. And even then, if some entities get out of sync, how you can recover from that. So we have some text on basically how to ensure freshness. Yeah, so I went through it quickly because I wanted to have time to ask the group. I think the authors believe it's fairly stable document. It serves as a good data point. People are already using it and referencing it. If I have the, sorry, did you have a question?
Please finish and then.
Yeah, please go ahead, ask the question.
Okay, sorry, Juan Carlos, first of all. I haven't read the draft, so I apologize if
No problem.
the answer is there. It's very, very useful information what you have here. What kind of radio interface were you using when you said that you were comparing processing power and power consumption?
So for the crypto stuff, we were actually not sending anything, but for the real application, we used Ethernet. It was purely just for
Ethernet on the cable.
Yeah, Ethernet on the cable.
Okay, so no radio or over the air or anything like that.
But it was
Okay.
wired. Yeah.
Thank you.
Yeah. So if it's okay with the chair, I would like to take a quick show of hands of how many
Sure.
people have actually read the draft.
So I also read it.
Or
Yeah, like
around
a couple,
15,
a dozen, yeah.
yeah,
More than
about a dozen. So then
Yeah.
minute takers, please write dozen.
So let's take quick poll. So seems that a big audience has read this draft. It's pretty positive. And I would like to ask.
I just want to mention that I'm Raghavendra, and I'm working on my thesis about security of constrained devices, and I found the references what have been used in the statistics as part of the draft and the presentation quite useful for my thesis. Thanks.
Okay.
So yeah, I would like to ask, so how many of you have think that this document is useful and could be adopted as a working document? Okay, more than a dozen. Close to 20, right? Yeah. So how many think that we cannot adopt this document? No. Okay, cool. Yeah.
Okay.
So yeah, anyway, we'll come back to the mailing list to confirm
Sure,
this consensus.
Okay.
Cool.
Great.
Thank you.
Thanks.
Thank you. So the next one is Tobias. I only use this.
Hello, my name is Tobias. I'm here because Daniel can't be here, and I'm working with him on the minimal ESP draft. The motivation for us on working on IPsec or ESP is basically something like that. If you consider a lot of devices in a infrastructure, something like a house or a university or whatever, the current status is you secure your device with DTLS against the cloud. And if you now add like health sensors, you do the same. Sorry, is there a pointer?
Yeah.
Yeah. So there are a few problems with that. There are a few privacy issues because you always send the IP address of the device you're actually using. So someone could track you, even could track your health sensor, and therefore could derive diseases or whatever just because of addresses. And it's also difficult to manage. Like if you're the owner of such a domain, it's very difficult to manage and to update. So what we are considering is using IPsec or ESP to establish something what we call domain security, so that you secure your devices against the gateway, and this gateway is secured with IPsec against the cloud or any other VPN connection. That makes it easier to provide privacy because you don't actually send the addresses anymore through the internet, and it's also easier to manage a domain. If you're the owner of a domain, you can easily like update the security. So we believe that ESP or IPsec ESP complements the toolbox of IoT towards DTLS and DICE. It has some significant features to secure the IoT. First, you can provide domain security, what I just showed, and it's also capable of multicast security. You can secure any transport layer you want, and it avoids like privacy issues, what I just said, like if you for a specific application or port. It's also very flexible because you're not like DTLS, you're independent of a key exchange. You can use any key exchange protocol you want. The obvious one is IKE, and we already have minimal IKE v2 as an RFC of this working group. But you can also use it with like radio key exchange protocols like DEX, which is very common in IoT devices in the moment. There is a RFC for multicast key exchange, and you can use it with any other. You can even set up it manually to establish the keys. The goal of minimal ESP is to provide guidelines for the implementer to remain fully ESP compatible to the RFC. How to build the ESP fields without a lot of computation, and also which ciphers should be implemented. This is already part of a working document in the IPsec ME, which points out some IoT specific ciphers. So in the next version of minimal ESP, we would probably add a reference to this RFC once it comes out, how to read it. So the basic idea is how to implement ESP with guidelines for the developer. Just to show you the basic idea, that's the ESP packet. You have a sequence number to identify the security association on the endpoint. So on the point which receives the encrypted packet, you have a sequence number, and then you have a payload which is padded to the IP alignment with the pad length and the next header which points to the, for example, UDP packet in the payload. And then we have an integrity check. So what we want to say in minimal ESP, how to use these fields as a developer. For example, for SPI, you could use IP addresses. For the sequence number, you can instead of using a counter, you can, for example, use the time, because the only requirement is that it's increasing all the time. To avoid padding, we have some recommendations on that. And yeah, so in our belief, IPsec ESP is a valuable option for IoT. 6low working group on Monday agreed that ESP is good to have in the IoT toolbox. IPsec working group just worked on a few drafts. For example, implicit IV was just adopted as the IPsec ME working group, that you don't have to send an implicit IV for counter ciphers. And like the one I mentioned, the cipher supports for specific IoT requirements. And we already have minimal IKE v2, so we think that we should have an ESP, minimal ESP also in the working group. Thank you.
Suresh Krishnan, so have you gotten any comments on this current draft from any security people, like specifically IPsec people?
Yes. For example, Taro is involved, and like the chair of IPsec is involved in this work on ESP.
Okay, Brian, are you gonna volunteer to review? That'll be awesome.
Yes, I have to cut a line right now.
Yeah, Brian Wise, I did just briefly look at it, but I can do a review. It looks like you haven't actually cut any bytes out. When you say minimal, it's really about the methods of filling the various values,
Yes.
making it easier for the constrained device.
Yes,
So-
there is no compression involved. That's why we're
Right.
here in LDAP. Compression is another draft, but that is just to give implementer a guideline on how to implement ESP, not
Right.
to compress it.
So I just wanted to mention, as opposed to IPv2, which really did, the IPv2 minimal draft did really actually try and reduce some of the payloads and such.
Yes, minimal IPv2 was actually the motivation of that.
Okay, sounds good. So if the working group does adopt this, like I'll figure out like how to get some more, like Brian volunteered to do one. I'll also talk to the secretaries to figure out how to get more review on this.
Sure. Another question related to this is that because I see you also have two drafts related to the ESP in the 6 law working group. What's the relationship of these two documents with the document you just presented here?
The ones in 6 law are going to compress ESP or the payload. This one is just an implementation guideline how to minimal implement ESP without going out of the borders of ESP.
Michael?
So, well, exactly, that's
Name?
Daniel Migo, one of the co-author, Ericsson. So the main difference between the DIET and this one is that with this implementation, we allow a very small implementation that is interoperable with the existing deployment.
Okay. So is there any open source support on this or any code available online?
We implemented it on Contiki.
Okay. You contribute that? Or
It was actually started to develop on from someone in Sweden, I think. He
yeah, I
implemented
know the
ESP.
Contiki.
Yeah. No, I
so
mean
what
the
have-
ESP, it's already implemented in Contiki and that's open source.
Okay. Great. Any more comments
No,
from
that's
you?
all.
So I would like to ask how many people have read the draft? Handsome, 5, 6. So, so how many is the audience in? Yeah. We can ask because since that audience is not enough, who has read draft? Or we can ask? On the list, okay. Yeah, the AD suggests we confirm the consensus on the list, and hopefully we can get some views from the security people.
Okay.
Great. Thank you. Thank you, Tobias. Okay, we come to our last item on the agenda, which is from Carsten.
So who in this room knows what RFC 7228 is? Okay, good. So the
No.
This has been out for 2 years now, and the question came up: is it maybe time for an update? After 2 years, this may be a little bit surprising, but it turned out that the draft actually was, or the RFC actually was quite useful. And there are two things that could have happened. Well, the world has moved since, of course, so is there maybe something new that we want to take account of? And the other one is that we might simply find that there is terminology missing, or that we run into terminology every day that is not clearly defined, where we have different words for the same thing or the same word for different things. So it might be an idea to update the draft with that. So given that it's probably going to take a year or two to do this, the next version would be maybe 2017 or 2018, so it's not that bad. So let's talk about two areas of potential work. One is terminology for platforms. So most people know 7228 for class 0, class 1, class 2. One thing we noticed is that people have big trouble distinguishing big computers from small computers. Big computers are sometimes also very small. They're called Raspberry Pis and so on. So we probably need some terminology that distinguishes between the microcontrollers that 7228 really is about, and the big computers, the computers that run Linux and which also may be pretty small in the end, but they have quite different characteristics. So in the software update workshop, we seem to pick up the ARM terminology on this. So within ARM, you know, they have these Cortex-A processors and the Cortex-M processors, and we started talking about A-class and M-class devices. And of course, every Trekkie knows that we are living on an M-class planet, so this is very good. And we can now decide whether maybe according to this terminology, the big processors should be J-class processors. But okay, so this is one point where we definitely need additional terminology. We also have found that the two classes, the two useful classes, class 1 and class 2, we identified sometimes are two cores, sometimes there's maybe a use for a class 3 or a class 4. So for instance, it would be useful to identify a class that actually is powerful enough to run something like JavaScript by name. We might want to introduce subclasses. So this might be another place where it might be useful to do some work. Then we have discussed crypto capabilities. So simple things like we have access to an AES accelerator, maybe interesting, or we have AES instructions in the CPU. I'm not quite clear what that could be, but maybe it's worth looking at different platforms and trying to classify them in the crypto capabilities. Finally, we are seeing more and more microcontroller class platforms that actually do have some protection capabilities. Memory protection units, memory mapping units, even some have CPU flags like kernel versus users. We have trust zone or secure elements. We have tamper-proof capabilities in very many platforms because people just don't want their source code to leak, their implementation code to leak out, and so on. So maybe it's worth looking at those capabilities and defining classes for that. You have a Java comment?
No, me.
You have a comment.
Do you want me to find to you finish the presentation or no?
No, go ahead.
Okay, Renzo. We are also in ACE having problems defining clock capabilities of the devices. Some don't have time awareness at all. So fresh token validation cannot be done the way you do normally out. So you need nonce-based methods. Some devices have relative time capabilities, and some devices might be clock wall synchronized. So to express the problems we are facing, we also need maybe on a document like this, a clear definition of the capabilities of the node.
Yeah, that's a very good point. I actually ran into the same problem already. We could maybe talk about power constraintness some more. So we have some basic terminology in there. I'm not sure how successful that terminology has been. I'm not hearing it in everyday exchange, but that may be just because people are not aware of it. And maybe we also can look at these sustainable power and energy total parameters and maybe build something like classes. So we all know that there's a watt class IoT and a microwatt class IoT, and they are very different in many aspects. Finally, we could look at terminology for networks some more. So I found out that we often have difficulty grasping the different MTU properties of networks, and in particular with LPWAN coming in we have networks with ridiculous MTUs. And so we should have classes of ridiculousness here, something like that. Also, maybe the fact that these have sustainable bit rates in the millibit per second range also gives rise to some classes. We have new kinds of asymmetry. So in LPWAN, we often have very powerful base stations that talk to very simple battery-operated devices. And this is a bit different from the 6LoWPAN case, where mostly all devices are of the same capability level. And finally, I think the mobility question that we managed to ignore in 6LoW for 10 years might also come in some form. So as you can see, there are a number of areas where we could start defining things. And I already have one volunteer for the clock or time-based issue, where Renzo has already done some work there, so I know that he is interested in this. What I really would like to assemble is a group of people who would like to contribute to that. So I will be pushing out a draft, blah, 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 7228 bis, and then I will start collecting ideas.
Carrie Lynn, yeah, Karsten, I agree with your initial comment that this has been extremely useful, because I remember in the early days of discussions, people were thinking that a Raspberry Pi was a constrained device, and of course to us it's a supercomputer. But just to follow up on your point about memory consumption, an example of the world changing would be if somebody has perfected a small fuel cell, the size of a watch battery, and those things. Moore's law is not going to save us here. Somebody has already made, the point in one of the earlier conversations that there's no reason not to pick a CPU that's capable of doing the work you need, unless you're powered by battery. So I think I agree with you. Maybe the point is that there's not enough awareness of the power constraint. I'm talking about electrical power, not CPU power. So it'd be good if the next version could take that into consideration.
Yeah. So do you have specific classes in mind for that, or take it to list?
Something I think we should think about.
Yeah.
I'd be happy to help.
Yeah, the line is card. Yeah, please continue.
Christian Groves, again, I support the work on this. I'll also note that there's already work undergoing on the co-op working group on the transport negotiation. They're proposing to extend this around transport availability. So I might want to merge that into the draft.
This is Anna Minaburo from Clio. I agree with you about the problem we have in LP1 to describe the new constraint of these networks. Then I can work with you describing this. Because we have a new scale, then we are sending packets per day and not per second.
Right, that's the millibit thing here.
Manuel Bacelli, INRIA. I fully support this work. I think RFC 7228 was already very useful, and revision could be could extend this usefulness. However, I think that if we want this document to be really useful, there's a trade-off between describing like so many classes and all these things, and I mean. Obviously extreme cases like one class per device, right? So we don't want to get there. So I think there should be two phases in developing this document. Really, first, like really kind of assessing, okay, what has changed, and then try to reduce the number of classes to the maximum somehow. There's this trade-off.
Yeah. So one outcome, for instance, might be if Renzo is doing a lot of work, we might have a second draft that just discusses this. Like we already have a draft for crypto and so on. So I'm very open to moving things between drafts.
So
yes, AD comments is allowed.
No AD hat. So just an individual discussion as an individual. I'm just wondering, right? Like if RFC is the right format for this, right? Like since it's something that's like evolving pretty quickly, I would say, right? Like so 70 to 28 is like if you look at the number, it's too young to be obsoleted, right? And I'm just thinking like, so there's like a couple of ways of doing this. Like one of them is like probably like some kind of wiki somebody maintains. Another one is like probably keep it as a draft, right? Like keep it as a working group draft for a bit and give it some time, maybe like a year or two, like just hold on to it and then do it. Like I just want like the working group to think about that as well.
Yes.
So my quick answer to this would be terminology is most useful when we have consensus on it. So this is really a place where wiki is not sufficient. You need to build some consensus about it. But keeping the draft active for some while and collecting things, there I completely agree with that approach.
Yeah, the problem is that we still don't have the draft yet. We are waiting for it.
I can do the draft.
Yes. I think this is a place to call for contribution for all the people who are interested in this, and we can discuss over the list.
So Carsten, like, so you can still do a consensus call without a draft, right? Like, so you can see if there's like adoption consensus, and then Carsten can post 7228 as bis 00, and then you can continue working on it. So don't let that stop you from trying to adopt that.
You could adopt the RFC and as a working group document.
Exactly. No, I'm not kidding here. It's been done before. Just do it.
Okay, thank you.
Okay, thank you. Yeah, meeting ends. We are pretty precise sometimes. Thank you for the presenters and also for the commenters. Okay, have a nice weekend. Anybody need to sign the blue sheet?